All right, how's everyone feeling today? Second day of the conference, after lunch, you are all in a food coma, am I right? Yeah. So this is going to be a nice lighthearted talk. I want to talk through a project I've been working on almost a year now. Some of the life lessons I've learned from there, and what you can do to do something similar, how you can control Raspberry Pis with your phone using Python. If anybody in here has been to Huntsville Pi or the web developers meet up here in Huntsville, this is the same talk there. So if you don't want to be bored, you've already seen it, it's okay to stand up and leave. I'll be okay, I promise. No takers? All right, so intro time. Hi, my name's Pat Leofor. You may have known me from previous talks like Practical Computer Science. I promise you if you were in that talk, this has no audience participation, so you can sit and relax, yeah. Some people were volunteers and they probably don't want that anymore. And this is not going to be a heavy talk. It's not going to be a math heavy talk. This is a nice, relaxing talk. It's after lunch So I want to tell you a little bit about myself. So I work at Adtran. It's about 10 miles to the west of here or so. About 2,000 employees. I do embedded telecommunication software. Do embedded C++, my day job, Python tooling on top of that. I'm also the Huntsville Pi organizer along with my cohort Ashley Hunt, who's not in the audience today. But it's our Huntsville's very own Python meetup. If you like Python, you're in the area, come check us out. I like music. I have guitars, violins, drums. I'm equally terrible at all of them. I think over learning the violin, while my wife can be in the same house as me when I play, but not quite the same room yet. So I've still got a little more to grow there. I like to cook. Oh, don't do this to me, projector. All right. I had projector problems last time, so I like to cook. This is me and my brother doing an Iron Chef competition. We do one every year. It's like a food hackathon. It's a lot of fun. Last year's theme was pears. I have not eaten a pear since because I was sick of them after that. Me and my wife and my son, he's now 2.5. We have another on the way, so we're really excited there. And they're actually the inspiration of this talk. My wife and I, we both like to play games, especially, let's reset the projector connection so that we have a stable connector. If not, it's going to be like a dance floor where we just flash on and off every time. So my wife and I likes to play games. Legend of Zelda is one of our favorite ones. In addition to video games, we also like board games. Who here plays board games? Few hands, awesome. I tried to get my son into it. He was like 6 months at the time. He was not interested in playing Dominion. He wanted to eat the cards. There's a game I like called Mice and Mystics. Anyone have played Mice and Mystics? No, it's like an RPG in the box. It's a lot of fun. I'm going to tell you about my favorite character in Mice and Mystics. His name is Nez. You know why he's my favorite? He's a tinkerer. I love tinkerers. What is tinkering? Well, that's something. So did you get all of that? Technology. All right. Tinker, to repair, adjust, or work on something in an unskilled or experimental manner. Yeah, that's me, except I don't like that word unskilled. I like the experimental aspect of it. No one wants to think of themselves as unskilled. I am though. But I like to experiment with things. I like to boil down tinkering with, I'm always looking for problems to solve. I don't always have a whole lot of time to solve it. Cooking, music, family, these things take time. And honestly, I like all of those things more than programming, but I still like that problem solving. So let me tell you about my problem. This is my problem. No, not that I have a son, that's cruel. But there's a lie in this picture. Anybody who has had a kid can tell you that when you're raising a young child, they don't just sleep in the crib like an angel. They sleep wherever they see fit. It could be like, I put you down on the couch, you're asleep. You're in my arms while I'm doing a task, they're asleep. So here was our dilemma. This was my wife and my dilemmas. Like I said, we like to play Legend of Zelda. Breath of the Wild came out just as our son was like 1 month old, so it's perfect. He likes to be held, but he's really not doing anything yet, so we're often holding our son, rocking him while playing Zelda. The problem is he'd fall asleep in our arms, and we have a blaring video game in the background with a projector with bright lights. Like, we really need to shut that off because that's going to wake him up. But anyone who's raised a child knows you can't just be like, here, sleeping baby, let me move you and jostle you and put you over here. You're going to wake them up, and you're already sleep deprived. So I said, well, I wonder if I could do a project that could solve this. And I thought, I know, I have an idea. Alexa, shut off the projector. Well, shouting at Alexa will also wake up your baby, I have discovered, so that won't work. And I thought, you know, my wife and I were millennials. We always have our phones on us. What if I could create a phone app that could control my projector? Now, yes, I could use a remote as well, but we had a little bit of foresight and thought, you know, young kids, remotes, who knows where those remotes end up? But we always have our phones on. One time, I found my TV remote in between my front door and the storm door. And I don't know how, because my son was like 6 months old at the time. Like, there's no way you open this door. But we searched for, like, did the dog eat it? I don't know. So remotes are unreliable in our household, but we always had our phones. So I set off on a project. I first looked at, yes? I have a new idea for a project then. Thank you. So, there's all sorts of ways we can solve this. I'll be honest, part of this was like, I want to go do something fun. I haven't like tinkered in a while because I've been raising my son. So I looked at off-the-shelf solutions, and so who can tell me what IoT stands for? Internet of Things. That's right, the S stands for security. There is no security with IoT in the most case. And that's not my own joke. None of my jokes are original, fair warning. I did not want to buy something off the shelf because most of them required external communications out to something in the cloud. There's a few things that were a little pricey outside my price range that I could have done it staying within my network. But I really don't want any of my network traffic, like for controlling things, automating things around my house, to leave my house network. That's just a mental block I have. I said, I'm going to build my own. And I always have an XKCD, or I try to. I like yeah, there's 14 competing standards or products. 14, that's ridiculous. We need to develop one universal standard that covers everyone's use cases, and now there's a 15th way. So what I'm going to tell you about is my 15th way, what I've created to solve an already solved problem. But hopefully I can convince you that, yeah, there's something useful here. There's something cool about this. And if not, I'd still like to hear your feedback. Throughout here, I'm also going to be telling you the pro tips I've learned for when dealing with a side project. This was my first serious side project that I published. I wanted to impart some of the knowledge I've had there because it can be daunting going here. Know your reasons for starting your side project. My reasons for this specific project was I wanted to write a phone app. I wanted to use the Raspberry Pi my family bought me for Christmas. I wanted to learn how to build a circuit. And this is a learning project, it is okay to fail. Those were my reasons. What were not my reasons, I don't really care about money, I'm not going to sell this app, you know, this is just for fun. And I also don't want to constantly update my phone app every time I change my mind. I am a fickle individual. I like to play around with things, set things up, tear things down. I don't want to spend all my time just doing app development every time I change my mind. Also, do your side projects in super small increments because you will get distracted. I promise you. Life is fun. It gets in the way, but it is fun. Go take advantage of that. And if you have your side projects in super small increments along the way, it will help. And so I'm going to go through the 3 increments I went through here for this project of how to solve turning on my projector on and off through Python, through my phone. So, step 1, I wanted to say, how do I control a projector with a Raspberry Pi? I have a Raspberry Pi, I've never built a circuit before, what do I actually do? Well, so a remote for a projector operates on infrared. It sends an infrared signal to your projector. The projector, or whatever electronic device that you have a remote for, knows how to respond to that and will do certain things. And so I looked and said, well, if a remote can do that, I should be able to get that little LED that's on the end of a remote, and I should be able to buy that. And now, projector. This happened in my first talk. Every time I wanted to go do something, like, every 10 minutes it just black out. So you're going to have to bear with me. I'm not sure what that problem is. I just have to reseat the connection. So I was afraid my circuit was going to look like this. This is what I thought all circuits looked like. I had really no idea. When I wanted to start learning, I said, all right, I'll grab a Raspberry Pi. Raspbian is a Debian flavor that goes on a Raspberry Pi. I know Linux okay, so that wasn't too hard. I found this book. This book, if you're interested in building circuits, I cannot recommend it enough. It teaches you everything down to, here's a simple battery and an LED, to getting up to chips that do timing. And it takes a very hands-on approach. At one stage, I didn't know how a relay works. So think of it like a light switch. And they said, here's this piece of a relay. I want you to take an X-Acto knife and pry that thing open so you can see how it works. I'm like, this is fascinating. The book's telling me to destroy things. That kind of gave me a little bit of comfort, I can learn this. So if you're interested in building circuits, if you're interested in circuit design, this is a great fundamental book. It does not replace the electrical engineering background. For hobby projects, I love this. And so this is what a simple circuit looks like. I have a battery, that's where that V is. I have some current going through the circuit. Right over here, this triangle is my LED. So I wanted an infrared LED. I knew those existed. If you look at the end of your remote, you'll actually see an infrared LED there. And then I have a resistor to protect the circuit so I don't fry my LED. This is the most basic circuit that book taught me to do. I said, I can build that. So I got my Raspberry Pi and said, all right, now what? Where do I go from there? I mean, this isn't a battery. How do I deal with it? So you'll see all these little pins on the side of a Raspberry Pi. What happens is there's a pin map for those. And this tells you what every pin does on a Raspberry Pi. You can go Google that. And so you'll see I have, in that top right, I have something called 5 volts. That's my power. Those greens are ground. Yellow is a GPIO pin, general purpose input output. You can use those GPIO pins to start driving circuits to turn voltage on or off. And so I went to Adafruit. This is just where you can buy a whole bunch of circuit parts. And I went and bought an infrared LED that had the resistor on it already. Said, you know what, I can go here. And then I said, I'm going to look at the instruction manual. Always look at the instruction manual as much as you don't want to. And this is what it told me. Connect the VCC, which was one of the wires that came out of that board, and ground to a 5-volt power supply, and the digital output pin to an output on your controller. So you can't see on this picture, but there's 3 ports on the end in this white block. That was my VCC, my ground, and my digital output. I can map those to here, where 5 volts my VCC, ground is my ground, and I just mapped, I think I picked 22, and that's my GPIO pin. I hooked those 3 wires up, and all of a sudden I could start controlling the LED just by flipping on that GPIO pin. How do you flip on a GPIO pin? Well, Python, of course. Python makes everything simple because Python. This is all the code needed on my Raspberry Pi to turn a LED on for 5 seconds and then turn it off. I import a GPIO library, I find out the pin number, I do some setup, and I output to that pin true, and then I output to false. I hooked up my infrared LED, I ran this program, and you know what I saw? Absolutely nothing, because infrared is invisible to the human eye, and I didn't realize that. But I swapped it out for a real LED, like a non-infrared LED, a yellow one, and it said, okay, the light turns on. I did a lot of swapping back and forth between an infrared LED and a yellow LED to make sure that I could actually make sure that everything was going okay. And then I said, okay, I now can turn on this. How do I know what signal to send? I started Googling for my projector model, and I found zilch, nothing, nada. So I then found an infrared receiver, which you can point a remote at, and it will capture the entire signal that's being sent from that remote, which is really, really cool. So I hooked this up to my Raspberry Pi. Same thing, you see the ground, that VCC, and that D pin, and the user manual told me exactly what to be reading for. And I said, okay, I'm going to use something called LIRC. This is part of the Raspberry Pi distribution. You can apt-get install LIRC, It is an infrared control library for C programs or Python programs, and it gives you a command line interface. So IR record, projector.conf, the conf files for something I created. I hit IR record, and it gave me this nice little walkthrough of, all right, point your remote at the receiver, press the power button 5 times, press the volume down button 5 times, press any button so many times, and then slowly learned how to map what signals became which keys. Once I knew what my power key was to my projector, I could use a command called IRSend, also part of that IRC package, to say, hey, send the power signal, the power remote signal, once from my infrared LED. So that was really cool. All of a sudden, I had a way to do this. I had to say what GPIO pins this was set up to, but I can now, from command line utilities, mimic what my remote was doing. And I found the remote for like a week, and I have not seen it since. So I'm really glad I was able to capture that when I did. And I did this, I was happy, and then I found out I had a range of 2 feet. I could stick the Raspberry Pi next to 2 feet away from the projector. My projector sits on a coffee table, which means I'd have to have the Raspberry Pi on the coffee table. I'm like, this is fine. And then I look at my 1.5-year-old toddling around, like grabbing wires and sticking things in his mouth, going, nope, 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 that needs to move. Next problem. I don't know a lot about circuit design. I mean, this is what it looked like. It looks super simple, and it's a mess of a breadboard. I didn't have to do any soldering. I know how to solder now. I'm going to do that eventually. But you can get going just with a breadboard and some wires. And you can see I have things marked. The yellow wires are marked so I remember what they are. But that's all this looks like. How do I do better with this circuit? I'm going to show you a really cool site I found, falstad.com/circuit. It is a circuit simulator which operates in real time, so I can switch this on and you can see circuit flowing through. You can see a bunch of graphs that I don't understand because I know nothing about electronics. But it's really nice to see how circuits interact here. And you can create your own, so I'm just going to grab something that's already pre-built. Don't ask me what this is, but yeah, I mean, there's some circuit I can start adding in. I can say, yep, here is a 7-segment LED, and I can actually attach wires from one point to the other, and I can slowly build up a circuit to map what I want. What's cool on this is as I was doing this, I could see, with my circuit, I'm only driving 30 milliamps through my LED. And I went back and looked at my data sheet, and what it told me was, hey, I can support up to 100 milliamps continuous, or a short pulse of a full amp. So I'm only at 30. If I can jack up that power, I theorized, like, yeah, well, maybe my light bulb shines a little brighter. That sounds simple. So I started playing around, and I found some open source designs to inspire me from. This was just, I like that I have this full coral background right here. It's really helping my ego right now. So I found this design online, said, all right, I can start copying this, I can start learning from this. I'm furiously flipping back and forth through that make electronics, but what does this symbol mean? Why would I do that? And finally I settled on a circuit that gave me 112, that's microns. Well, I found a circuit that actually got me up above what I wanted for the amps. I believe there's a typo on here, my apologies, but I found something that's like, all right, let me rejigger this circuit, I can start playing around with things, seeing how it really goes, and finally I got to 12 feet, which was just enough to sit the Raspberry Pi in a shelf across the room, and it works. I was happy. It's okay to get stuck, just keep asking for help. I had no electrical engineers at work, like, hey, how do I boost power to an LED? They said, use a transistor. What's a transistor? And then they'd go through and tell me all of that. And I'm like, it's okay to just keep asking for help. Google is your friend. I like to think of Dory. Just keep Googling, just keep Googling, just keep Googling. It's a good mantra to have to really learn through all of this. I have a Raspberry Pi now. From the command line, I can control my projector. Now I want to expose that through a web interface. Because if I can get it through a web interface, I don't even have to do it through a phone app. A web interface can get me pretty far when going through here. So anybody here, have they used Bottle before? Or, okay. Anyone use Flask? All right, Flask and Bottle are pretty similar. I'm going to be going through a Bottle web framework. It's a way to very quickly get HTTP requests into a Python program and respond to them. So, Bottle, let's take a look at it. This is a fully fledged web server program that has one URL, get hello, and then whatever name you put after that, and it will return a string printed in your browser that says hello name. From Bottle, import get and run. If you're not familiar with the syntax, this is a Python decorator. You can just think about it as like it wraps a function. That's all it's doing. It's saying, I'm going to convey some attributes and do some magic on this function here. That's the magic of Bottle, or Flask if you use it. Just by one simple decorator, you can say this function should be responded to over HTTP. I start my server, everything's happy. I actually get a web server out of that. Great. Now, I don't want to do much more work than I have to. So I want to say, how can I start really messing with Bottle? How can I make this really easy for people? I don't want to have to like rewrite Bottle pieces all the way through. I want it to be much more in my context of a domain. So I'm not great at like, yeah, I'm going to go invent the world. I'm going to go solve all these problems. I don't have the time to do it. That's my confession. I want the dirtiest, cheapest way I can do things, something that's flexible. And I don't want to update the web page every time I want to change functionality. Same reason why I didn't want to update a phone app every time I change functionality. I'm lazy. So, if you see an idea you like, feel free to use it. I really, really like that Bottle API. It seems very simple. So I developed a Python package that tries to mirror that API, but gives me a sense of buttons. And that gets us to RCFC, Remote Control for Computers. This is all it takes for me to launch a web server that has a button registered on it that when you hit it through a web page, it will go call this function. So I now have a mapping from a function to a webhook. And not only just getting information, but interacting with that button as well. Yes, question? What was that? So print data runs on like my Raspberry Pi, and then so this is actually doing like the action. So when I go through the web page, I'll see a list of buttons. I'll get to that in a second. And this just registers a button for that web page. So actually, you know what? Let's take a look now, just so you can see. Fair warning. This looks terrible because it's just meant to show me where like some default things. So let's say I need to make sure that my RCFC is running. So what happens is I have a really terrible looking web page, my apologies, and I have all these buttons here that I can click. I have some sliders, I have toggles. What's happening is every time I am interacting with one of this, it is going back to my Python program and actually doing operations on it. So the group toggle is set to false. If I go back and set that group toggle again, I forget which one's which. I see one toggle is set to true and the group toggle is set to true. What's happening here is only by just decorating that function gave me the functionality I needed. I'm actually going to show you what this demo looks like. Let me pull this up in my code browser. So that simple button that says easy, this is all it looks like in the RCFC framework. So I decorate a button, say this is the name of it, I give it a function, I say print that was easy, isn't it? Without doing anything else, that means that when I press the easy button, I see a message that says that was easy, wasn't it? And because this is Python, I can do anything in there. It doesn't have to be just print statements. It can be, I turn on a projector, or I turn off a projector, or I set up my motorized blinds, or I turn on my Philips Hue lights. Python can do almost anything. So now I have a nice, easy way that as I decorate functions, I get new functionality in my website without ever touching the JavaScript, or the CSS, or the HTML. Because if you looked at that, you know I'm terrible at those. Also, design your user interface first, README Driven Development. I put a lot of time thinking into how that decorator works. is because I thought through, I want it to be easy to use. I'm not going to be the only one who might want to use this. How can I make this so straightforward, so low cost to entry, that someone's like, yeah, I can decorate a function and get a web page that can start controlling things. It's all dynamic. And we're going to see that in a live demo a little bit later. So RCFC. You guys can pip install this today if you want. I've released a few versions of it. It's just pip install RCFC. I'm going to talk through how it actually all works. So there's kind of a pipeline here of how I'm doing this. I decorate a function which registers a button in my system. And then from there, I can allow buttons to be queried. What buttons do you support? Or I can associate buttons with a certain function. So let's take a look at decorating a function. All the decorator is if you have a Python function you want control over the web, you just put that @ sign. If you want a button, you do button.simple, text of the button, that's it. That's all that's needed to decorate that function. From there, I can register a button in the system. This is all done automatically. That decorator is the only thing the user has to do when they want to use RCFC. This is all the code needed that I did for registering a button. I have some registration calls. I'm saving off what type it is and what text is in there. All that register button does is appends that JSON to an array. So I have a big array of buttons that are all throughout here. I think I actually have, so associating that button with a function, we're going to take a look at that register call. That register button, 5 lines of Python when I did this presentation first, where I figure out what index every button is associated with a numeric index. So that easy button is number 0, the next button was 1. I create a root and bottle so that I set up the HTTP routing for the user, and then I save it off in a dictionary. That's all it is. And I'm going to take a look at the code. My whole entire main server file is like 140 lines of Python, and that's with a lot of comments. That registered button, let's see if I can find it. Oh, registered button is just here. Yeah, it still looks the same. Except now I can root buttons. Maybe 7 lines, 6 lines of Python. I try to make this super simple so that registration was a snap. Lastly, I want to have buttons be queried. This is what the web page does, so that's just return my JSON dictionary. There. So let's look at this from a sequence diagram. If I have a web browser, it's communicating with my RCFC backend. First thing it does is load the page. RCFC is then going to, the browser will then query all buttons, say, give me all the buttons you have. RCFC says, all right, here's all my button data, and the JavaScript of the web page will automatically create all those buttons for you, so that you don't have to tinker around with any of that. And then, when you do a button click, some button action is performed back in RCFC. That's all it is. You also want to make sure you want to build in ways to validate your progress continuously. Because if I try to do the phone app all along with this, and try to build everything up all at once, I would have failed. I would have given up. Because the web page is horrible, yes, but it got me validation that yes, this can be done. If I can do it with a web page, I can do it with a lot of the other things as well. Also, continuously test your project. Those of you who know me know I love unit testing, CI, CD, all of that great stuff. Continuously test your project. I'm using Travis CI for this, so every time I push up something into RCFC, just a cloud service kicks off, rebuilds my code, looks for errors. I've actually found an error in my code because when I went to the nightly version of Python, a version of setup tools changed, and that broke my distribution, and I could find that really, really quickly without me doing manual testing every day. In order to get Travis CI running, you just need a GitHub repo and a travis.yaml file. This tells me this is a Python project. These are what versions of Python to test against. Here's what to do when you install, and here's what you need to do to test. This is all that happened, all that I needed to do to get my CI pipeline up and going. Now, I'm not doing any continuous deployment. I'm not deploying out of Travis. I like to do that manually. But I know that, all right, I'm good with the latest versions of Python continuously. And so I am up on the Python package index, like I said before. You can use Twine if you've never used it before. If you have your own Python packages, Twine makes it really, really easy to upload and register things on the Python package index. That's super, super useful. It's like Twine upload name of tarball. You're done. You enter a username and password. So yeah, pip install RCFC if you're interested. You can do that right now if you want. It is Python 3.6 and above, because I'm not that interested in legacy Python at the moment, and I really like F strings. For those of you who use Python here, you'll know what I'm talking about. And here are the things that I support today. I have simple buttons, simple toggles, so on, off, left, right arrows, sliders, and color pickers. So I use these for my lights at home too, or I might have a button that's like party mode. Kids love that at Halloween because they come up to our house and our garage lights are flashing a different color every 5 seconds. They're like, your lights are so cool. I'm like, yeah, I know, thanks. It doesn't take much to like inflate my ego. A compliment from an 8-year-old is great. All right. You can also find this on GitHub, so if you want to contribute to this, feel free to. If you just want to take a look at the code, it's maybe 2 or 250 lines of Python total right now. I'm trying to keep it small. And we haven't talked about phones yet, because that's the interesting part. Web pages, all right, I've just repurposed bottom, nothing special there. Let's talk about phones. Here's back to my another confessional. Terrible at UI. Absolutely terrible. I mean, we saw that with this sort of crappy little button. Like, seriously, it's a dumpster fire of a UI. It's terrible. The 90s called, they want their site design back. I understand. So what can I do? Well, I'm like, I know. I'll go to an Android app. Let's go native. That would be way better. So I fired up Android Studio. I said, you know what, I'm going to learn Kotlin while I'm doing this. And oh my goodness, the XML was everywhere. I spent a long, long time trying to get an app. And I have not done app development before. If I were comfortable in it, I'm sure that I would have had a much better experience. But because I was not comfortable with it, that Android app really, really threw me off. Come on. Yeah, there we go. So here are my challenges, not only just AV issues. I tried to learn too many things at once. I tried to learn Android app development and Kotlin at the same time, so that way when I had a problem, I didn't know where I was going wrong. When you do a side project, you're going to just be like, I don't know, if you try to take on more than you choose. Learn only one new thing at a time. I learned that the hard way. Either learn a new language with an existing project, or learn a new project with an existing language. It will save your sanity, trust me. So I took a look at Ionic. Who here has used Ionic before? Yeah. Ionic is pretty awesome. It gives me like a that was easy button for creating Android apps and iOS apps. It's cross-platform. So it's based off Angular. I know JavaScript. I can read Angular. I haven't written a whole lot of it, but that was far more approachable to me than Kotlin was. So if I can just write an Angular website, Ionic will give me a whole entire web page off of that. And Ionic will let you deploy it to phones, which is really nice. It's done in TypeScript. I like TypeScript, so that's another plus for me. Kotlin, I just didn't understand. I may like Kotlin, I just didn't give it a chance. So it transformed my dumpster fire of a UI into something that I felt like I could install on a phone. That actually looks like it could be on a phone. This is a picture from, actually this is a picture from my phone. It looks the exact same on my browser. That's really nice. What it looks like on my browser, it looks like on my phone, and it's mostly native on my phone. There's some containerization voodoo going on. It's not actually native to a phone, but it has native plugins, which I'll get into in a little bit. So the Ionic CLI threw me away, or blew me away. I'm going to show you just like what a nice little example Ionic CLI was. If I can say Ionic Start. Every app needs a name. All right, someone threw me a name. Fine, I'll create the name. Pat is boring. And it gives me this nice little like menu of like, hey, what do you want to do? Do you want to create a side menu project or maybe a tutorial project? And I picked a tutorial project, and I had to enter in one command after I got all this set up, and it gave me a way to start testing out a phone app. Like out of the box, within an hour I had built a phone app. And that's a really, really good feeling. So the CLI was fantastic in helping me through there. Ionic documentation is fantastic. They have a whole entire tutorial section that really helped me understand what was going on, and it got me somewhere in an hour. Ionic CLI shares a lot of benefits with Angular, like live reload. The fact that I could edit a file, hit Control-S to save it, and then it would automatically like reload on my phone if I was linked to it was fantastic. It meant that I didn't have to wait for these long, like 20, 30-minute compiles of an Android app to just test out oops, this is too many pixels to the right. And has native plugin support. You can do speech, speech to text, you can do text to speech, you can integrate with GPS maps, you can integrate with Bluetooth. There's a full plugin infrastructure. It's running off Cordova, for those of you familiar with Apache Cordova, awesome, or PhoneGap if you've heard of that, that bridges that web framework, that Angular, to your native capabilities of a phone. So it's so much more than just running a website. It's cross-platform. I can build both Android and iOS applications from the same source code, which is fantastic. I don't have any Apple devices. I don't want to pay for the Apple developer fee right now. But if I ever do, I don't have to go reinvent everything. I can just say, Ionic, go build me an iOS app from my existing source code. And Ionic Serve. Ionic Serve is really cool. I'm going to show you. So I have my buttons running, and we saw how terrible that looked. I have my Ionic project right here, and I am going to hit Ionic Serve. So it's going to pop up a new browser. It takes about 5 to 10 seconds to spin everything up. And just like that looks so much better. That looks like, you know, someone could have paid me $1 to do rather than, please, I want my money back UI. And this all works. I can click buttons, has that nice little splash effect. It just looks nice. And just to show you going back here, if I go back to, actually it does not, looks like this guy's home. It got the buttons and then said, nope, I'm going to crash. Visual Studio, running this from Visual Studio Code sometimes is a little iffy. I think that whole entire Visual Studio process is dead. Let's restart it. Sorry about that. Actually, I'm just going to do it from here. I'm going to do it from the shop. We've looked at that code enough, so. As I click buttons, yes, I actually see, here's my slider being pressed, here's buttons being pressed. All I'm doing is printing out messages, yes, but you could do anything in those Python functions to control anything you wanted. What's nice about that Ionic Serve is there's actually a dev app you can get on your phone to test those things out incrementally. So let's go to the bottom of here. I'm going to connect on my phone to that Ionic Serve instance. I don't have that custom app loaded. It's just one of Ionic's apps that will work with any Ionic Serve. Takes a little bit. If you can't see that, there are actual buttons. I'm going to press them and you can see them start being manipulated up on the screen as I'm playing around on my phone. So we have color pickers. I'm doing that from my phone. And I just launched that. I didn't deploy a new app. Now I actually have the app to put, RCFC actually publishes an app as well. You can download that app too if you just use it, but for developing, Ionic made that really, really easy. So, we're going to write something live, because that's fun. Let's talk about a demo. Let's get into my temp workspace. Let's forget all of this. All right. I'm going to create some buttons from scratch, just to show you how easy it is. So, let's, did I stop this? I want to make sure everything stopped. So, actually I still need the Ionic Serve, my mistake. So, let's create a RCFC demo.py. All right, from RCFC import, I'm going to just do a button. Thank you, web browser. Button and a start. Nothing is server. I'm going to create a button, just a simple button. Someone shout out some text, any text.
Yeah.
Yeah. I didn't hear what the first person said, I'm sorry. So, meow. And what do we want to happen when we meow? Just print out meow. Let's also open up Firefox, just so you're what would some web automation look like? So I'm just going to os.system, Firefox, http DevSpace conf.com. And then I need a server.start. Let's see if I got this all right. Python 3.6, RCFC demo.py. All right, that is started. If I were to go back to here, I now have a meow. And when I click this, there's my Firefox instance, and there's the meow printed. In like 45 seconds of a live demo, I could just control that. I could do the same thing from my phone. If you install the RCFC app, you would get the same exact user experience as this, where you can say, you know what, I'm going to pick a device. I can say what IP and port number my RCFC server is running on. And when I go back to my buttons, it will load all those buttons up, and you can press them, and they will go do things. That's what I aim to go create with this project. So, last things about Ionic, it has APK support. So if you've ever played in the Android space before, like building Android APKs can be painful, especially on a Linux machine where I had to explore like 30 million build variables and environment variables to get that going. I still had to do that, but once I got that, I just did Ionic build. I actually think it's, no, I don't. All I had to do was like Ionic build Android, and it worked. It created the APK for me. I had to figure out some signing issues and get it up on the Play Store for the Google Play Store. But it was really nice that Ionic had that CLI just for me. And as I found myself doing things again and again, automate your repetitive tasks early. Because like I don't remember how to sign all my images, or I had to do like some alignment on those APKs. Those are the Android packages for those who have done Android dev. So automate, automate, automate. I have a shell script now in my project where I just issue it and it creates the whole entire build process for me. It saves so much headaches whenever you forget something 3 months down the line. Because remember, on your side projects, you will not have a lot of time and you will always be distracted. So this is on Google Play if you're interested. You can search RCFC if you wanted to do this. Like I said, you give it an IP address, you run the server on a Raspberry Pi on a computer. You can do this for like prototyping an app, you can do it for home automation, you can do it for some workflow. Use it for anything. And if you don't see something like, oh man, I really wish I could have a picture of a cat to say meow, just let me know. Or create a pull request. Let's keep building onto it. You'll find it on GitHub at RCFC Ionic. That is the Ionic project that's running the phone app. Just real quick, like when I say Ionic is super easy, that buttons page, this is TypeScript, is 120 lines of TypeScript just to render that buttons page. To render that device setup page where I gotta pick my IP address, let's see, is 70 lines of TypeScript, and my about page is a whopping 13 lines of TypeScript. I mean, there's HTML associated with this too, but again, we're talking like less than 300, less than 400 lines of TypeScript to get a full app. I'm super happy with that. There's a lot that Ionic does for you. So, this was a talk on RCFC, remote control for computers. Thank you for coming out here. You can follow me on Twitter. You can follow me on my blog. Those are the 2 GitHub links. I will have these slides available online. They're actually already online because of the Huntsville Pi meetup, but I'll have these specific ones for DevSpace up as well. And I'm hoping to have this on YouTube before too long as well. So if you ever want to see the recording of it ever again, thank you to our sponsors. Couldn't be here without you. I certainly know I wouldn't want to pay like twice as much of a ticket. Thank you, sponsors. If anyone's in the audience from one of the sponsors, thank you. And thank you guys for coming to DevSpace and coming to my talk. I appreciate it from everyone of you. Okay. Are there any questions?
You said you have it controlling your lights.
Yes.
How did you go through, you went through how you picked up the IR signature for your projector. How did you do that for your lights?
So my lights are Philips Hue, and the bridge for Philips Hue has a REST API. So I'm using Python's requests library just to do HTTP requests, then posting, turn on this light, turn off this light, change colors. I don't like the Philips Hue phone app that comes on the phone. It's a little limiting for me. I want to do a little bit more things. I have actually thought about, like, for Halloween, that party mode is actually like a series of things. I press a button and it does things in like certain chunks, so that I have like, oh yeah, do this sort of mode for 30 minutes and this sort of mode for 30 minutes. I have a tough time doing that through the default Philips Hue app. So now, just because I know Python and I know how to interact with my lights through Python, creating the phone app to do what I wanted to do made it really easy. Does that answer your question?
So were you able to find more information working with the Philips Hue?
Yeah, we got some time. Let's go take a look, if everyone's okay with that. So Philips Hue REST API. So if I go click Philips Hue API, see if I can find something here. I haven't looked at this for a while. Philips Hue API.
Oh, that's awesome.
Yeah. So yeah, they're doing it through like something like Postman or like just or through their web thing, and they say like, yeah, if you hit this API, you know, this is the error you get back in JSON. Here's the JSON you need to put on if you want to turn something on. And so just, if you still have to know how to do the things in Python if you're interacting with it, but because Python has so many libraries out there, I'm willing to bet someone's already done it. All I aim to do was, how do I make that really easy translate to a phone app?
Which library do you use Python to just send it?
So for the Philips Hue, I just use the requests library, which is an HTTP library. Just as like, you know, has a post method, has a get method. That's sufficient enough for what I use. Any other questions? I said it. Didn't want to keep you the full hour right after lunch. Everyone's starting to fall asleep, get droopy, but it's okay. Thank you, everyone.